the end of this, at the end of today's notes, but we'll see. Let me tell you guys, it is a sad, sad day for me. Sad day. And here's why. Usually when we do this day, I got everybody in class. I put you guys into groups. I give you guys multiple strands of licorice and ask you guys to cut the licorice into pieces of 2, 3, 4, 5, and 6-inch pieces. All right, so I hand out a pile of licorice in your group. You guys have rulers on you, and you guys cut those pieces into those lengths. It's a lot of fun. After we're done, you get to eat it. Unfortunately, no longer, huh? No longer. What do I ask you to do with these licorice, all the licorice pieces? By the way, I know it says in your activity 3 straws. No, we don't do straws around here. This is honors. This is honors. We do licorice around here. Not this year, though, unfortunately. All right, so what would I ask you and your group do with the licorice? I would ask you to pick 3 pieces and try to put them together to see if you guys could form a triangle and write down yes or no. And when I say form a triangle, it's got to meet at every vertex. You know, if you get 2 pieces of licorice and the third one goes like that, that's not a triangle for me. So I give you guys about 10 minutes to explore what sets of measurements would form a triangle and what sets would not. And you guys would come up with the following. Take a look. Hey, if I took the 3, the 4, and the 5-inch piece, that would form a triangle. Hey, Mr. Carlino, our group found another one. 3, 5, 6 formed a triangle. Hey, I got another one over here. What is it? Oh, 2, 3, 4 formed a triangle. And I'd say, hey, good job, kids. Yeah, that's awesome. Great job. And there would be some arguments too. That didn't form it. Yes, it did. And I had to come over and separate people and tell them who was right and who was wrong. And then I would ask groups, all right, well, you came up with great yes ones, but did anybody find any sets that did not form a triangle? Oh, yeah, we did. 2, 3, and 5. We cannot get those pieces of licorice to form a triangle. And then one last group would say, hey, we also found that 2, 4, and 6 could not form triangles. That would be correct. And then we'd all look at our results and we'd say, hey, there we go. I want to make sure everyone's looking at what they have to look at and not trying to do the homework. Look at that magic power I have. I can close people's tabs on the computer when they're not where they're supposed to be. All right. So then I would ask the entire class, all right, do you notice any patterns? Look at the values we had when we formed a triangle versus the values we had when we did not form a triangle. Do we see any patterns or relationships? Because again, here's what I'm trying to get you guys to realize. In a triangle, you cannot just have any 3 lengths that you want. If I have a triangle that's got a side of 2, 3, 10, I hate to break it to you, that's not a triangle. That's not going to form a triangle at all. All right, you cannot have any 3 lengths that you want. It has to fit into a certain rule. And that rule already has been said, but if anybody would like to chime in and tell me the rule again, that'd be great. You can only form a triangle if you know what about the 3 sides.
You can only form a triangle if you know the 2 sides will end up to be greater than the 3rd side.
Any 2 sides you pick has to be greater than the 3rd side. So look at this triangle that formed a no here. 2, 3, 5. Well, here's why it formed a no. Because 2 plus 3 is not greater than 5. It's equal to 5. The sum of any 2 sides needs to be greater than the 3rd. Not equal to, greater than the 3rd. All right, and that is our triangle inequality theorem for today. In a triangle, sum of two sides is greater, not greater than or equal to, is greater than the third side. All right, you cannot have any three side lengths you want. It may not fit our theorem. Questions on the theorem? Pretty easy, right? Sum of two sides has to be greater than the third. All right, let's test it out then. So I have 5 different triangles here in the first example. 5 different triangles. I give you the 3 lengths, and I'm going to call on everyone and see, hey, would that form a triangle? If you're going to tell me no, you better be ready to back yourself up with an explanation why it's no. So if I have a triangle with side lengths 1, 2, 3, can I get a triangle out of side lengths 1, 2, and 3? Emma, not here. Escaped. Here we go, Luke. 1, 2, and 3. Can I form a triangle?
No, because 1 plus 2 is equal to 3.
Oh, look at that. Just like the old kindergarten days, huh? 1 plus 2 is equal to 3. It needs to be greater than 3. 2, 4, 5. Can I get away with having a triangle side lengths 2, 4, 5? 19. Sean, 2, 4, 5.
Yes.
Yep. Any 2 sides you add up will always be greater than the third one. 5, 5, 6. 5, 5, 6. Ooh, here we go. Zach, 5, 5, 6.
Oh yes, that's triangle.
Yes. Oh, don't mute yourself yet, Zach. I got a bonus question for you, boss.
Yep.
It will form a triangle. What type?
Isosceles.
Yeah, let's go. There you go. Good. First, it needed to be a triangle. Now that you told us it was isosceles. Good man. 8, 3, 21. What do you got for me? Woo, Hannah. 8, 3, 21.
No,
Why not?
because 8 plus 13 is 21.
There you go. It's got to be greater than 21. That's a no-go. 10, 20, 25, kids. 10, 20, 25. Can I roll with that? Kyla, can I roll with the triangle with 10, 20, and 25 as sides?
Yeah.
Yeah. All right, so it seems like we're pretty good at this. All right, we're pretty good. Now I'm going to get a little tougher on you. Here's what I'm going to do now in the next couple examples. I'll give you 2 sides. You guys tell me what the third side could be. So this first one up here, my 2 sides are 4 and 7 inches. Go ahead. I'm not going to call on people here because it's going to take a while. But give me possible lengths of that third side, making sure it fits into our new theorem here. So I got 4 and 7. What could be a possible length of the third side? Anybody want to start this off?
Would it just be anything greater than 4?
No. What? Great. Put a little hundo up there? I don't think so. I don't think so. 4 plus 7. I don't think that's going to be greater than 100. All right. Hey, we tried. Let's go. Anybody else want to put a side length up there for me?
It could be a number from 4 to 10.
4 to 10, huh? Ooh, so we're saying 4 works. 5, 6, 7, 8, 9, 10. Well, hold on. Let me go 3. 3 wouldn't work, right? 3 plus 4 is 7. Good job. And then let me keep going. What about 11? Nope. 4 plus 7 is 11. All right. I got you. So anything between 4 and 10, right? All right. Now, I just don't want to list those out, though, every time. All right. I want to organize it in a mathematical way. I don't know if you guys, I'm hoping you guys did this. Tell me if you did or did not last year in Algebra 1. You guys dealt with compound inequalities, 2 inequalities at the same time. Something like this. You guys, yes, no, maybe? Okay, good talk. I'm going to let X here be the third side? That's going to be, x is going to be my third side length. So I'm going to put x in the middle. What I need your help right now, guys, is what number should I put on the outsides? X is between. That third side needs to be in between. Well, if you look at what we have here, we have a 4 to 10, right? Okay, hold on, though. That's not going to work. Because you guys said it could be 4 or it could be 10. But my inequality does not include 4 or 10. Anybody remember what I got to throw on those inequalities so to make sure to include 4 and 10? Because right now, my inequality does not include 4 and 10. But that's possible values. What do you got?
Greater or equal to or less than equal.
Remember the or equal to, kids? That means it includes those numbers. I got bad news, though. That's not going to work. Everything between 4 and 10, including 4 and 10, that's not going to work. Why? Ready? Ready? Could this side be 3.8? Is that possible? Yes or no? Could that side be 3.8 and still be okay? Could I have 3.8?
Yes.
Yeah. Why, guys? Hey, 4 plus 3.8 is 7.8. Greater than the third side. But look at the inequality. 3.8 is not part of that inequality. So I can't have it. Look, hey, I could go 3.1. Right? 3.1 works. Hey, why don't we get real nuts? 3.01 works. But all those numbers are not part of my inequality. Help, help, help me here. Adjust this inequality. Because right now I don't have 3.8, 3.1, or 3.01 in there. So those 4 and 10, that's not going to cut it either. Suggestions?
Anything greater than 3 or less than equal or equal to 10. Definitely.
Or 10.
Yeah.
Well, does it? Okay, if I put a 10 here, 10.1 works. Right? 4 plus 7 is bigger than 10.1.
Less than or equal to 11.
Oh, now we want to go up 1 and go to 11. Let's see. Would that work, guys? Anything between 3 and 11? Yeah, I think so. Anything between 3 and 11 would work. Not including 3 and 11, so I'm not going to put the or equal to there because it can't be 3 and it can't be 11. But anything between that seems like it works. So we finally got it. Anything between 3 and 11. I don't know about you guys. I'm exhausted from doing that. That took a while to figure out it was going to be between 3 and 11. There's got to be something quicker, right? There's got to be something quicker than going through, listing all the possibilities, playing around with a darn inequality and its or equal to's and seeing if I'm correct or not. That takes way too long. There's got to be a quicker way. There's got to be. Oh, wait a second. What sides did I give you at the beginning? 4 and 7. And what were the outsides of our inequalities? 3 and 11. Anybody tell me a way I can use my given side lengths to find what my inequality is going to be right away? I started out with 4 and a 7 and figured out it has to be between 3 and 11. Go ahead.
If you take the the lower number and subtract it by 1, you get what's less than x. And if you add the 2, you get what's greater than x.
Okay, 50-50 on that one. Add them together, yep, you get the 11. Forget the one less than the lower one, just subtract them. Okay? Take your two sides, guys, subtract them, you get 3. Take your two sides and add them, you get 11. Done. That's how I can tell what my sides have to be in between every time. Add them up and subtract them. All right? So let's do that. Let's do it for the next one. What if my two sides are 9 and 17? 9 and 17. So that tells me that my third side is going to be somewhere between 8, 17 minus 9, and 26, 17 plus 9. Whoo! That's a lot quicker than listing out 9, 10, 11, 12, 13, 14, 15, right? A lot quicker. And then I'm going to turn it over to you guys now. What about 11 and 20? Two sides, 11 and 20. Means my third side's got to be between what? Right at the top. Vinny, my third side's got to be between what?
9 and 21.
There you go. 21? $21?
Oh, 31.
One job. Between 9 and 31. So a little easier there, guys. Okay, add them up, subtract them, you'll get what the third side has to be in between. Whew, good job. And then I got one more for you. You can start the assignment. Oh, you know, anytime I can throw out on a graph, it's going to come out. So can I have a triangle with these three vertices? Q, R, and S. All right. How am I going to know if these are vertices of a triangle? Well, I know when I add up two of the sides, it's got to be bigger than the third side. How am I going to find the side lengths? I'm not even going to ask anymore. We know distance or Pythagorean theorem. I am not going to break you guys up into groups. We're going to do this all together here because I get a little nervous making sure you guys, if you know exactly how to use this distance formula. All right, so we got to find the length of each side using the distance formula and see if two of the sides are bigger than the third. Let's do it. Let's start with QR. All right, going to ask somebody. Let's get a little help. QR. Oh, 18, helping me out. Oh, and let's roll, big dog. Give me the X coordinates for Q and R.
6 minus 2.
6 minus 2 squared. How about the Y coordinates for QR?
5 minus 6.
5 minus 6 all squared. Got it. All right, so it looks like 4 squared, 16. Negative 1 squared, 1. I can't stress this enough. Anytime you square what's in the parentheses, it should always be positive. So QR has a length of square root of 17. I can't break that down, so I'm going to leave it. Square root of 17. All right. Can I get a little help with SR, please? Side SR from somebody. Whoa, Vinny, back at the top. You got redemption now. Redemption. Don't screw it up. SR, X coordinates.
1 minus 6.
All squared plus Y's.
2 minus 5.
All right, there you go. Redeemed. All squared. All right, guys, ready? Negative 5 all squared. Positive 25. 2 minus 3 is negative 3. Negative 3 all squared. 9. So we end up with the square root of 34. Cannot be broken down either. So we'll leave it square root of 34. And we got one more side, QS. QS in the house here. $12. Lucas, here we go. X coordinates for Q and S.
I didn't get them.
I'm not asking. I'm just asking for the X coordinates in Q and S that are right on your notes.
Sorry. 2 and 1.
2 minus 1 all squared. And how about the Y coordinates as well? Okay, good talk. 6 minus 2, all squared.
Sorry, I thought you were asking.
It's all right. It's all right. You had one job. It's all right. All right, here we go. QS. Let's see. I got 1 squared and I got 4 squared. Oh. I'd like to say it's isosceles, but I don't even know if it's a triangle yet. So I'm going to wait on that. All right, you ready to see if it's going to form a triangle or not? Sum of 2 sides has to be bigger than the third. Easiest way to test is always to take the 2 smaller sides and see if they add up greater than the third. And I know what's going through your mind right now, and this is exactly why I'm doing this problem. So we're going to say, what is radical 17 plus radical 17? Is that bigger than the third side, radical 34? And I'm sure, how many people at home right now? No, it's not. It's equal to each other. It doesn't form a triangle. Whew, we must have missed the radical unit last year in Algebra 1 if we're saying that. All right, these two are not equal. That is not how you add radicals, is just by adding the number underneath. Oh boy. That is not how we do it. All right, use your calculator. Watch. Ready? Everyone go ahead. Grab your calc. Go ahead. Little radical 17 plus radical 17. I'll get there too in a second. About 8.2. So this is equal to about 8.2. Radical 17 plus radical 17. How about the square root of 34? Oh, what do you notice? They're not equal. That's about 5.8. So when I added up 2 smallest sides, it is greater than the third side. So we can say QRS is a triangle. Okay, please watch out for that. That's not how you add, you do not add radicals by adding the numbers underneath. All right. I don't know if they threw radicals at you last year, but that's not what happens. All right, use your calculator to see if one side's bigger than the other. Any questions there I can answer? Solid session there? Now you guys have over 10 minutes to start the homework. We're not logging off either. We're staying right where we are. You guys can get on the online textbook and get going. You can probably get a good chunk of it done. Let's roll. And we're working on the math, please. I'm sorry if you have something due in another class. That's not my problem. Okay, we're focusing on the assignment that's due tomorrow. That's not what I wanted.